Okay, all good. Right, so hi, I'm Dan Keeley. 6 years apparently. May or may not be true. But yeah, I work for Rabua. I'm principal data engineer. And this talk was inspired from a rather geeky video I was watching about how to get hardware devices into production and deployed at scale. And it was like one of these classic YouTube videos, 10 points. And I was watching it, I was thinking, hang on, this applies to data engineering, and it ties in with that whole thing about learning from other areas. As data engineers, we've historically been somewhat slow in learning from the good practices in software engineering, but I think there's even more on the hardware side. So it's just a fun run through what went through in that talk. So this is the guy, John Teel. He used to work for Texas Instruments, and now he builds his own devices and gets them produced and built in China and retails them in America. So the other sort of key points about this talk. So in data, I don't know if it's true across all of AWS or across every scene, but there is a real focus right now on productionization. Partly that is down to funding, right? So AWS is now tightening up funding, and damn right, you know, what's the point of paying forever endless POCs that go nowhere? But also, you know, we need to deliver that value, and this stuff is valuable. OpenAI's recent report about the percentage of what people are using it for and what it could be used for shows there's massive potential here. So, but we've got to get it to production, and this is the things that we need to focus on to get it to production. And interestingly, a key part of this in hardware, and I would argue in data engineering, is predictability. And predictability is an interesting challenge with AI. So yeah, so there's the concept. And then, yeah, so failure modes as well. So a lot of data projects that fail, or POCs and so on, they're not failing because people don't know AWS, right? We all know AWS, we all know the best practices, we all know the services, but it's failing because it's a prototype that went into production too early, maybe requirements were all over the place, but maybe it was all about the testing, right? So the data wasn't reflective of the real world. There were duplicates, there were retries that cascaded. Oh, have we seen that somewhere? And you know, and they weren't looked after when they went to production. And so, you know, this is software. There's going to be bugs. So commit to fixing those bugs once you're in production. Okay, so there's 10 points. So I'm going to aim to hit each of these in 2 minutes, so let's go. So number one, freeze the design, right? So who's heard of scope creep? The bane of our lives all day long. So this is absolutely true in hardware, right? So more true in hardware, because once you've changed the design, there could be massive impacts on that, unexpected. So you must draw a line in the sand. You must freeze the design. It must obviously be valuable, whatever it is that you're developing, and you must get it to production. This does not really map to an AWS service, so this is already a little bit tentative. However, in order to have that process of getting something, you know, smoothly into production, we need that delivery process to be simple, easy, efficient, and safe. So we've got to be using CI, CD, so on, and we've got CloudFormation for that, right? Or Terraform, or whatever your favorite tool of choice is. There's another subtle thing about this sort of freezing the design as well. So we do a lot of migrations, and you can't be changing, you know, moving the platform whilst you're trying to migrate. So again, really keep things simple for yourself. Freeze the BAU, freeze that change, do your migration, and then resume from there. And don't forget your infrastructure config, your metadata that configures your application, all of that, that's all part of your code. You can't carry on changing the infrastructure whilst you're in a change freeze. Okay, if it moves on. Okay, so in hardware, number two, they call design for manufacturing, right? So you can build a prototype, you've got your breadboard, you run it on your desktop, it's running in a nice environment and it's all good. That can't automatically go straight to a factory in China and be pushed out at thousands of units. So you've got to think about how that prototype can go to production. So what does that mean in data engineering or in AWS? So I would argue, and perhaps maybe the previous talk was a little bit anti-serverless, but I would go for the serverless approach. It simplifies things massively. I would go for managed services, right? Who wants to be running Presto on their own cluster? No. Who wants to be a DBA these days? No one, right? Let AWS do all that. It's boring. Concentrate on the interesting stuff. One exception might be managed airflow, simply because the managed service is super expensive and you can just run it on your own EC2. But there's always an exception that makes the rule, right? But also you've got to think about that design for manufacture, like getting it into production. You've got to cover that monitoring. This is my point 3, FinOps. So you've absolutely got to have those alerts, you've got to know what's going on, restrict access, all the SCPs, that's absolutely all part of getting something into production. And you need to be able to copy and paste this, right? So not just have one part of your app that is wonderful and absolutely perfect. The whole lot, right, needs to be of production quality. And that single-threaded Python app, right, that isn't going to cut it. You've got to think about retries, failures, scale, all of that. Okay, number 3, supply chain. Isn't that topical? So not only have we lost Middle East, and everyone said, oh yeah, we're never going to lose a whole region, right? But not only did we lose a region, but the associate regions got completely overloaded. So it was just a complete cacophony of failure. But now we know we are going to lose region, right? It is going to happen. But this happens all over the place. So who's had to productionize a product delivered from a data science team that is using out-of-date libraries that they've just built from source code and don't build, in production. Who's done that before, right? All of us. So you've got to productionize all of this. You've got to use up-to-date libraries all day long. You've got to have monitoring in your pipelines to detect these things when things go wrong. And again, looking for things like security alerts when a library develops a thing. As long as you can just bump that library, test it, unit test, away you go, then you're laughing. Also, you've got to think about the AWS service dependencies as well. So obviously, we lost DynamoDB for a while when in US East, and that murdered a ton of AWS services. No one can really know about that, but you've just got to think about what things might be going on. You do know, if you're using Glue, you know Glue relies on S3, so you've already got some dependency knowledge there. So yeah, use service quotas, use the health dashboard, and monitor your suppliers. Step 4 is about designing for test. So when you build a piece of hardware, the factory will test your device, but maybe every 10th device or 100th device, up to you. They'll test every device if you want, it just costs more. But to do that, you will build in test points on your circuit board that serve no purpose other than testing that particular circuit board in the factory at that moment in time to see if it works. It doesn't serve any other purpose, but it's for measuring signals, voltages, and so on, right? This is unit testing all day long. So we need our code to be unit testable. And this is where AI is super interesting, because a lot of the AI, the code that is developed, AI does have a habit of being quite, cutting things down into almost comically small procedures, but they're eminently testable. And it's very good at that. And even more than that, even if you write the code and you've built the application, AI is amazing at generating the unit tests for that code that you've written. So, yep, as you can tell, I'm a bit of a fan of AI, which I'm taking that this room is perhaps not so much, but whatever. And you could argue, if your code doesn't have a unit test, right, it's not production ready, so it doesn't go to production. End of, right? I mean, there's always going to be exceptions to the rule, but we've got to know the rules, right? If you know the rules and you break them, that's fine. It's when you break them, you don't know them, that you're having a disaster. Right, in hardware, certification is a big thing. If you're dealing with mains voltages, different certification. If you've got a transmitter on board, Wi-Fi, Bluetooth, whatever, you've got to do various certification for electronic noise, and away we go. So what do we think that would mean in terms of AWS architectures or data engineering? Any ideas? Just yell it out.
ISO, SOC, PCI.
Yep.
There's 3 of that.
Yeah, all good, absolutely. Anything else? So I think possibly there's a gap here. I don't know that this entirely applies. We can think of things like frameworks, governance, absolutely. There's well architected, of course, which is more about the info rather than your application. We can also think about enforcing standards like code formatting, pre-commit, really basic stuff like that. But I don't think there is much here. Perhaps this is something we should look to the hardware community and see how could there be something. Could there be a certification framework for a data pipeline in AWS? What would that look like? Would it even work? We have Prowler, right? Prowler assesses your infrastructure to AWS best practices. Can't we have that for Python code? I don't know. That's a thought, a question. Number 6, stress testing. So all day long. So this device you've built and you've got on a breadboard on your desktop is running in your room at 20 degrees and a consistent humidity with a consistent voltage. As soon as you put that device in a car or a vehicle, it's having to deal with a range of voltages from like 11 volts up to 15 volts. It's dealing with negative temperatures all the way up to when the sun comes out, if it ever comes out, you might be getting up to 35, 40 degrees in the car. And it's dealing with ridiculous levels of humidity and vibration, right? So you've got to test that, right? And this is absolutely the same in production all day long. So you've got to do load testing. So the classic tool JMeter, which has just been the standard tool for load testing all day long, and it can hit anything. It can hit a SQL interface, it can hit any HTTP URL or whatever. But we've also got fault injection simulator, a bit of good chaos engineering might be fun. Oh, let's simulate a region going down. That would be fun, wouldn't it? Oh, we don't even need simulator now, it just happens. So so we need to check these things, right? Check what happens when you hit your provision capacity. What happens? Do things queue up? Does that cause problems elsewhere? Does it just get rejected? What do you want it to do? So, and there's some big anti-patterns here. So I've seen teams, it's very tempting for cost as much as anything else to do your stress testing in production. Not many people realistically have a pre-prod that is exactly the same as production, but that is what you should be aiming for. But yeah, people who do stress testing in production, it's kind of not testing, it's gambling. But needs must. Ideally, you should have a separate environment. You can hammer the living daylights out of it. You can monitor your costs, and you can see what happens. So firmware. So number one in a hardware device is the firmware. In all devices these days is becoming much more complex. You can run all sorts of languages now, not just C++. You've got Python. You can run a lot of these hardware devices that have embedded GPUs. You can run machine learning on embedded devices. It's quite incredible, and that firmware needs to be predictable and run in a deterministic manner. So you need to, for any given input in a hardware device, you do expect it to do the same thing. When you drive in your car and you press the throttle, you expect it to accelerate, right? It needs to be predictable. Specifically on AI, this is a challenge, right? This is something we are battling right now. There are plenty of things in AWS to start working towards this. I think something that is becoming more popular right now is just actually reducing the scope of what the agent can do and just constraining, where it can go. And don't forget human in the loop. or you must always make your solution, whether it's AI or not, even if you just got a parsing algorithm or whatever, if it fails, then okay, fine, we go to a human, they can deal with it. If you automate 80% of your manual tasks, you're still up. So it doesn't matter, right, if 20% are still going to the human. But if you just ignore them or they just get lost, then that, that's not production, is it? So. Number 8 is test fixtures. So when the factory is testing your device with those test points that you put onto the board for them earlier, they need a harness that holds your board in place, because all of this is automated, right? And a test fixture is this blue thing, which is actually a device that holds your board. And obviously it needs to be built as a piece of hardware for the purposes of productionizing your solution. So you won't necessarily do this from day one. You just want 10 boards just to test the process, check the factory, see if they can do what they claim they're going to do. But as soon as you go mainstream, you're going to need this in place. And I didn't really realize this existed, but we use the term test fixture, don't we, in software development, in Python. And this is exactly what it means. So think about your local development environment. So you've got to make things easy for your developers to test. So local stack, SAM local, local Lambda execution, DynamoDB local, all of this stuff. You can get a long way now on your laptop testing what you've got. So you should be fairly confident something's going to work before it's even going anywhere near AWS. But also think about fixtures on the cloud side. So we must have separate accounts, right? So you must have a separate test account, separate to production, and all deployed with the same stacks, whether CloudFormation or Terraform or whatever. That's your consistent fixture, which is supporting your code. And also don't forget mock endpoints as well. You probably don't want to be hammering the billing service, so you can mock that. There's probably an extreme use case, but have a mock endpoint, test it, prove it, then deploy. And then production, so production validation. So once you've gone to production, you do still need to check that the device is working. So once you've plugged it into the car, your tracker or your black box or whatever it might be, you do need to test it's working, test it in different vehicles, test it in lorries and vans and cars. And this is absolutely aligned with integration testing. So all day long you can have your code that has got 100% code coverage on your unit tests. All the unit tests pass, it's all wonderful, it's all black, pilot, no warnings, wonderful. What's going to be a problem with that? As soon as it goes to production, or even your test account, hopefully, you'll find that, it might be deployed in a Lambda, it can't access your RDS. The security groups are misconfigured, the glue jobs are timing out, the event bridge rules don't trigger because the pattern is wrong in production or in that environment, or there's a bucket policy or an SCP that prevents you using that service. So this is integration testing, and this is probably the last thing that that people do. Thankfully, we mostly all do unit tests, but getting to the point of doing integration tests, it does take a lot more work. But we do have CloudWatch Canary. I noticed there's no official icon for this one, so I copied this rather amusing fake one. But it's cool. And also, when you're using a Canary, run one from outside of AWS, because you might have your service that works internally, but if the external endpoint is not visible or is blocked or is not working, you will never know. So your Canary won't fire. So you need to be running that outside as well as inside. So. And then the 10th one is about yield optimization. So we're really stretching the limit now of how this applies to software. However, a low yield means you're losing money on every unit, right? So maybe every 10th board fails test. So they're not going to repair it. It will just be thrown away. And there might be some part of the manufacturing process, or your board, the tracks are too close together, and whatever. There might be technical problems that have in your design, meaning your yield is really low. Hopefully, you can sell it at a high enough price that won't matter, but that's super important. But yield optimization in AWS or data engineering is all about cost. It's the FinOps thing, isn't it? So if you've got a model or an endpoint or a prediction that is requiring the latest NVIDIA GPU, even if it provides amazing value in that prediction, if you've got thousands of customers, that just isn't going to work. You won't be able to get enough GPU, you won't be able to charge enough for it. You need to optimize it so that either it runs on maybe some AWS hardware or even just on normal Graviton or whatever. You've got to make that model cheaper to run so that it will work at production scale. Okay, so to wrap up, predictability is better than features all day long, right? So startups are absolutely terrible for this, where they are always chasing features and never delivering on any of them. And you know, all your investors are saying you need AI, and they're like, well, what for? And I don't care. We need it anyway. What's the point of all this, right? Just get that predictability, get it working, get it proved that people are using it, and then iterate, because iteration is easy. It's getting it out there in the first place that's harder. Production will break. This is software. There will be bugs. Just deal with it. Develop, have a solution. You know, look after these things. If something's in production, and you know, the code rot is a thing, right? Code that isn't touched will break. It just happens. Freeze, we talked about that, and optimize continuously. So, and this is the point about AI, right? So AWS gives you all these tools, thousands of tools. Production grade is, are you using them? And if you're using AI for vibe coding, the AI isn't going to offer you these things. So the AI is only adding value if you tell it to use these tools. And you can only do that if you're an experienced engineer who understands, well, software engineering, data engineering, DevOps, whatever it is. So we're not going away anytime soon. And there's a guy on Slack who is on LinkedIn, who is vibe coding Slack. And I don't know if you've been following this, but it's absolutely amazing. By day 3, he'd got the whole back end and front end done. And then he spent the rest of the following days using all the agents. It is all done with agents and vibe code. He didn't write a single line of code himself. And he's been using them to do things like check each other's code, build the unit tests, do security scanning on it and all that. And I think he's on about day 8 or 9 now or something like this. He's over halfway through. And so far, and he's compared it to Mattermost, which is an open source Slack, and he's compared it to another one which I didn't recognize. And so far, his solution, which is vibe coded, so far, because he's prompted it really well, actually has less security holes than Mattermost and less code, which is surprising because AI is like really verbose, right? Thousands of lines. So that's absolutely astonishing. So things are changing, so we need to follow on. So any questions? So there's 2 things here. This is me on LinkedIn, so feel free to send me a connection and I'll answer any questions. This is the original article, which is a LinkedIn article on my LinkedIn as well, but it also links to the original YouTube video as well, and I even got a comment from John Teel on the article, and he thoroughly enjoyed the article. So yeah. Any questions?
One question, and
yeah.
then we'll wrap up. One question, Matt.
If no one else has.
Yeah, go for
Well, I'll be around after.
Yeah.
So for the stress testing, what do you use to generate synthetic data, or do you test with production?
So that's a really good question. So AI is amazing at generating synthetic data. So you can give it a schema, and you can say, just generate some test data for this, as many rows as you want, and away it goes. Or there's nothing better than production data that's been anonymized, because then you've got the right quantities, you've got the right cardinality, you've got the right patterns. Yeah. So.
Cool. Thank you.
But you say you give the schema, how do you verify that test data AI is giving is properly fine? It's going to work. because AI give good data,
Yeah.
but not always going to be perfect.
Yeah.
How
So
do you verify that?
yeah. So the question is, how do you verify that the data is a good test data
'Cause
set?
in
Yeah.
some point
Yeah.
can fail. If you
Well,
really
this is
can't-
why a production data set is the ideal, but obviously you've got issues with PII and whatever. But also you need to scale that data above and beyond. So you need the variance. You'll always see more variance in production than any test set you generate.
But you give a margin, you give a variance.
But yeah, but don't underestimate how hard this is to do, because there's no point in having a test data set that doesn't match production, because you won't hit the limits that you hit in production. So,
All right.
Cool.
Thanks, folks.
cheers.
Thanks, Dan. So these are speakers tonight. Round of applause again, please, for Matt and for Dan.